everyone, my name's Tola. I work for Lloyds Banking Group as a data scientist. And today I am here to talk about unit testing in Pytest. And can I say, I definitely wasn't expecting a full house because I didn't think unit testing was sexy enough to other people, but it turns out it is. So it makes my job today so much easier. So, what am I going to do today? What I aim to achieve today, I'm sure most of you have heard the term unit testing, especially if you work with developers, and how developers love to emphasize that unit testing is best practice when it comes to software development. However, for people new to the research field or people that actually currently work in it, this is an area where there's lack of clarity as to what is unit testing. How do you get started? When is it needed? And also what tools and toys are out there available to actually get this done. So what I plan on doing today is obviously introducing this concept to you. And how I plan to go about that is basically sharing with you what's helped me develop as a data scientist. Because I can tell you, when I started in my career, I was not a fan of unit testing. But that's by the way, we'll come back to that later. So, how I aim to obviously achieve this overview that I plan to cover today is share with you what I've learned over my time being as a data scientist has helped me develop so far. Because if you think about the typical workflow of a data scientist, we typically tend to work quite closely with the business to understand what the problem is. Then you move on to your data understanding, working quite closely with your data engineers to explore what data sources you've got available to you. And very quickly you move on to cleaning your data set, doing your whole feature engineering, feature extraction, and then doing the more sexier stuff, which is the modeling, evaluating your model, and you're constantly iterating through this phase. But in the process of doing that, you are reporting your progress to the business and starting to share some results to the business. But as a data scientist, what I find that happens quite often is you build up a lot of technical debt when you're doing this because you want to iterate very, very quickly. And you tend to do most of this in Jupyter Notebooks and you have 0 tests written, but then you're constantly sharing results to the business. How do you know your results are actually as good as you think they are? Without any unit test. And this was a game changer for me. So I've mentioned the term unit test a few times already, but what is unit test? In very, very simple terms, it's essentially testing the smallest component of your code base, whether that be a method, a function, or a class, and ensuring that it does what it's been written to do. But what's key about this is you're testing this in isolation of the rest of your code base. So for example, if you write a function, for example, to return prime numbers in an input range, you want to write a test to ensure that in various scenarios, that's exactly what your function is doing, and it's not doing anything funky. Basically, that's what unit test is. However, mentioning this already is making some people by default feel uncomfortable, because I remember I used to, right at the very beginning, I'm just like, hold on 1 minute. So you want me to write lines of code to check my existing code base, but it's not necessarily going to improve my model performance? So what's the point? Seriously? But it actually has its benefits, and this is some of it I've learned it the hard way, and that's why now I totally buy into it. And here are some of the reasons why I think unit tests is essential, especially when working as a data scientist, or if your role involves building something that's going to be a product for an end user. Number one is a big, major one for me, which I've fallen into that trap one too many times. It's the fact that when you write unit tests, it helps you catch bugs in your code very, very early on in the process. Hence the reason why I encourage people to start your unit testing quite early, rather than obviously procrastinating and leaving it for when you're ready to start refactoring your code for some, deployment. But secondly, it helps validate the current and future implementation of your function or methods or class. Because when you think about it, you write a function now, and then let's say a few months later you decide, actually I want to refactor that to make it more efficient, you go back to it, you make changes to it. If you've got no test written, this is what people typically do. You make changes and then you call your function multiple times and different examples, and if it's all good, you're like, yeah, my function's good. But then when you come back later and you make further changes to it, you have to go back to that old school way of calling your function again on multiple arguments just to check it's okay. You are kind of wasting a lot of time. But if you've got some unit tests written and you refactor your code to make it more computationally efficient, all you have to do is just run all your tests, and if it's all good, you're good to go and move on to the next interesting thing. But also, one thing I have heard quite a lot is the fact that sometimes it's easier to understand what's happening in your code by reading the test than reading the actual code itself. So one thing I find is unit test is some form of additional documentation to your code base. Good. But also, overall, it's to help increase confidence that what you've written actually does what it should do. But finally, I really like this last point because it is heartbreaking, some of the code that I see in the workplace, where I think when you're writing your code base should be full of modular and reusable code. If it's not, it becomes really, really hard to test. And I've got an example here. Can everyone see that okay? Really sorry about that if you can't. But I've got a very, very simple function here that is very little, and by default you expect it to just do one thing. But this function basically takes in a data frame, does some pre-processing to it, fits it to a logistic regression, and returns the fitted object. Already that function is doing one too many things, when your function should have a single responsibility, just one simple thing. So when you're writing your test, you're just testing that that function is doing that thing and is doing that thing correctly. Because this little function, already you can split it into two different tests where you've got your pre-processing function that takes in the data frame and does the manipulation for you. And you can have a training function as well, which is model agnostic, because here it's quite explicit that that function would only work with a logistic regression. But here you've made it a little bit sexier. I say that word quite a lot, I should stop. Where it can take in any estimator of your choice, and that makes it more reusable and a lot easier to test. And already, if a new colleague was to join the project already, this is much easier to understand than that. So when you get yourself into the habit of writing unit tests, by default, it helps you write better quality code in your code base as well. But it's not just about writing unit tests. You want to write good tests as well. That is, you want to think about every possible scenario that could happen with that test, with that function, and check for it, because it's quite easy to forget the edge cases as well. So we're moving on to the Python side of things slowly. There are three main unit testing frameworks in Python. You've got Pytest, Nose, and unit test. For this session, I will be focusing on Pytest because I think it's pretty awesome and it is quite popular. But why do I think it's awesome? Usually I struggle to come up with reasons, but with Pytest it's a no-brainer. I mean, for starters, it's so easy to get started with it. The syntax is lightweight. But also, if you currently got tests written in Node or unit tests, you can pretty much get started with Pytest with little or no refactoring required at all. But also, Pytest has got three main powerful functionalities which has helped it increase in popularity. And there's markers, parameterization, and fixtures, which I'm going to introduce in a few minutes. But Pytest is open source, so you can pretty much go onto your laptop, pip install, and get started with it. And it's got a very active community of developers constantly making it better. So, I mean, if this is something you want to contribute to as well, feel free to get started. And what's cool about it as well is it's able to automatically detect tests in your project, run it, and report it. But how does it do this? It's got this process called a test discovery, whereby if in your project you follow the Pytest naming convention, is able to automatically detect the test in your project and report the status of them. And these are the naming conventions that you have to follow if you do decide to use Pytest. That is for your test modules. They either have to begin with test underscore or end with underscore test, while your test functions need to begin with test underscore, and your test classes just begin with test. So this is one of the core functionalities of Pytest. So let's move on to looking at just a very, very simple basic test. But Pytest is so simple. Here, I've written a function which is asserting that two lists are equal. And by default, you look at that, they are equal, so you expect that to run successfully, right? I go into my command line. Sorry, I've had to take screenshots because due to infrastructure reasons, I could not do a live demo for this, so I've had to resort to screenshots and just talking through it. But you go into command line and you run that module. But what's great about Pytest is when you hit run, it gives you some more information, such as what Pytest version is running, what Python version are you using, some information about your kind of environment. But also, it tells you how many tests is found and the status. So here is 10 minutes, found one test and that passed. So yay, I'm happy, move on to the next thing. But what if I write a test I expect to fail? How does Pytest handle that? So I've added another test here where I'm asserting that these two lists are equal, but clearly the last index, the items are very different. When I run this through Pytest, Pytest tells me that it's found two tests, one is passed and the other is failed. So I'm running this in verbose mode, but what's great about this is not only does it tell me that the second test is failed, but it also tells me why it's failed in plain English, not a whole lot of jargon. If you want more jargon, you can get it, but it provides you with good enough information. That is, the items in my last index are different, so I pretty much know why my test is failing and how to fix it. But also, with Pytest, what's great about it is for these examples that I've just talked through, they're using the inbuilt Python assert statement, where you can use it to assert that an expected output is equal to your actual output, because in comparison to using frameworks such as unit test, it's got different assert variations that you might need to use based on whatever inequality is required. But with Pytest, you just use your assert and whatever inequality is required. But another thing about it is the fact that using the context manager format as well, you can also test to ensure certain exceptions or warnings get raised in your code base as well. So here, I've got an example of where, obviously, when you divide any value by 0, you expect a 0 division error to get raised. And that's essentially what you're testing here. Like I said, have the context manager format. In one of the arguments is what is the exception type that you expect to raise. If a different exception gets raised, your test fails by default. Or if no exception gets raised at all, your test also fails. Same as Pytest warnings. So at the beginning, where I was talking about why Pytest is really cool and you should look into it, I mentioned three key functionalities of Pytest, which are fixtures, markers, and parameterization. So I'm going to start with markers. Markers essentially in Pytest allow you to run a subset of your test all at once. So for example, if you think about Pandas, which is a very, very popular open source library, they have got loads and loads of tests. So if you were to go into Pandas and make some contribution, and obviously you have to run the test that is assigned to that feature, instead of you sitting there waiting for every single test in your Pandas code base to run, you can just apply markers to the tests that are being affected. So when you go into your command line and you run Pytest and you specify that marker name, only the test associated with that marker gets run, and that saves you loads of time, so you can pretty much iterate very quickly. So to bring this to life a bit is, I've got 3 test examples, and I've applied some markers to them. Essentially, how you mark your test is by default, you just apply some sort of decorator to it, which is at pytest.mark. Whatever marker name you decide to give it. And what's good about it is you can apply multiple markers to a single test function. So the first one's got 2 markers, the bottom 2 have just got single marker. So I've just decorated them with different marker names, and I go into my command line. The first one, I've specified running Pytest for the marker name passing. And what's cool about this is Pytest comes back to me telling me that it's found 3 tests, but it's deselected 2 because they haven't got the associated marker name, and it's ran just the one that's got the marker name passing to it, and that ran successfully. So I'm all good to go. While the second one here, I'm running Pytest for the marker name mock. And what I've got, the results I've got is I've got 3 tests that was found by Pytest, and it's only successfully ran 2 because they've got the marker name that's specified. So this already is a time saver. Moving on to fixtures. These are actually really, really popular, and a lot of people use them for setting up and tearing down resources when it comes to testing, because this is the way of feeding in, whether it could be a database connection, a URL, or some sort of input data, which you want to pass to your test method. And essentially, how fixtures work is they're just a normal function that have been decorated using @pytest.fixture. But how they work is the fixture gets executed first before the test method, which has been applied to. So to bring this to life a bit is, here, I have defined a fixture. Like I said, it's just a normal function with a decorator on top of it. And this is my test method here, where I'm feeding in my fixture as an argument, because typically that's what you do. You pass your fixtures into your test methods as an argument, and I'm asserting that my fixture is equal to the word string, because my fixture should return that as an output. And when I run that runs successfully, which is great. The thing about fixtures is when you define them in your test module, they are restricted to that module only. If you want to make them available to other modules, the convention is you create a Python file called Pytest, and you put all your fixtures in there. And by default, you can call those fixtures from any of your test modules. And Pytest knows to go to your Pytest file to find it and runs it. I mean, if that's not cool, I don't know what's cool. Unless our definition of cool is different, which it probably is, but it's fine. And finally, parameterization. This is also a very easy way of running a single test method multiple times, changing the input argument at each iteration. So instead of defining your test methods multiple times and then changing the argument, all you have to do is decorate it using the @pytest.mark.parameterize, and the first argument is the input argument, which goes into your test function, and the second argument is an iterable of your core values that you want to pass into your function and see what the result is. So if you go into your command line again, you run Pytest, or you can run py.test, so different ways of calling Pytest in this. What happens is I'm only running this test function, but I've got five values that I want to test it for. So I get 5 different test results, and that pretty much tells me that that's run successfully. Well, not all of them, because one of them is failed, and that's the argument 0, because I'm asserting that my input value is greater than 0. So when it hits 0, that fails, but it carries on to the end, but it does report that, okay, so I've run this test on 5 values and one of them is failed, so it's up to you to fix it. So that's parameterization. But one thing I want you all to take away from this, because this was a game changer for me. This book, Python Testing with Pytest, absolutely changed my life when I read it. It's not a very thick book. I think it's just got over 200 pages. I don't know who this guy is, so I don't get any money from this if you were to buy it, but it is such a great book if you want to get started with Pytest. Honestly, I read it, I went onto Twitter and I had to tweet about it, and I'm not really a Twitter person. I was like, this book is phenomenal. If you want to get started in Pytest, go get yourself one, honestly. And he's got a podcast as well, but I don't know, the music is great, but the minute he starts talking, it's a bit of it goes the other direction. Just stick to the book. So to find out about the awesome features of Pytest, you get because I've spoken about fixtures parameterization. You can parameterize fixtures as well. There's some custom plugins,